This is lesson 1-3, Exploring Real Numbers. Here I've drawn a chart for you so that we can easily or more easily talk about what real numbers are. Now in algebra, all we deal with are real numbers. When you get to algebra 2, you'll learn about a whole other category called imaginary numbers. But for now, we're focusing on real numbers. Real numbers are broken up into two categories. Either they are rational or they are irrational. A rational number is simply a number that can be written as a ratio. And what is a ratio? A ratio is just a fraction. So a rational number is any number that you can write in the form A divided by B, a fraction. So you may remember rational, or I would write on here that it is a ratio slash it's a fraction. So some examples of rational numbers might be 7, which could be written as 7/1. But we'll get rid of that for now. We know that all whole numbers can be written as a fraction, or -3. Also, the number 0.3 repeating, which as a fraction is 1/3. Therefore, it is also a rational number. The decimal 0.25 is a rational number because its fractional form is 1/4. So it's any number that can be written as a ratio or as a fraction. So all these would be examples. Any other negative number, also 0 is a rational number. And so let's talk about irrational numbers and what are irrational numbers. So notice that rational numbers include fractions, decimals, positive numbers, negative numbers, and also zeros. So let's talk about rational numbers or irrational numbers. What are some irrational numbers? One very common irrational number is pi. Pi, if you put it in your calculator, is 3.141592654, and then your calculator stops. But your calculator doesn't stop because that's where pi stops. Your calculator stops because otherwise it would fill the entire screen with numbers, and that'd be a little overwhelming and not very helpful. So notice that pi, which is an irrational number, when you look at this decimal, there's no pattern. The numbers are all over the place. We have no idea what would come next here. We couldn't say, oh, this is a 1, then a 4, then a 1, then a 5. Okay, so then this is going to be a 1. No, we have no idea what comes after 4. It's a crazy number. So irrational numbers, ir meaning not, so they are not ratios. And also, I really like to just think of them as crazy numbers. They are crazy. We have no idea what they're doing. So notice it doesn't repeat and it doesn't end. So you can also say they are non-repeating or non-terminating decimals. Another example might be the square root of 2. If you put the square root of 2 in your calculator, you get 1.414213562. And again, that's all your calculator gives you, but that doesn't mean that's where the number ends. It simply means that's all they're going to give you instead of filling the whole screen to confuse you. So again, no repetition, so it's a not repeating decimal, and it's a non-terminating decimal. That's an irrational number. Notice that with our two decimals we put in here, 0.3 is a repeating decimal. It has a fractional form, 1/3. 0.25, it's a terminating decimal. It has a fractional form, 1/4. So rational numbers are repeating or terminating decimals. So you might want to write that in here. Repeating or terminating decimals. Whereas irrational numbers, they don't repeat or terminate. Okay, so let's move in one more to integers. Integers, all integers are rational numbers. But as we go down in the circle, we get a little more specific. So integers are rational numbers, but integers exclude all fractions. So integers are negative numbers, positive numbers, 0, but no fractions, no decimals. So let's write that in there. No fractions, no decimals. Integers don't have any fractions or decimals. It's just negative, positive numbers, or 0. Then when we move down to whole numbers, we get even more specific. All whole numbers are integers, but not all integers are whole numbers. Whole numbers are numbers like 0, 1, 2, 3, etc. So no negative numbers. It includes 0, but no negative numbers. So you can put that in here. No negatives. No negative numbers. And then we get down to natural numbers. And natural numbers, again, we're getting more specific, so we're leaving out more numbers. All natural numbers are whole numbers, also integers and rational numbers. But in natural numbers, we leave out 0, so we just have 1, 2, 3, etc. So no 0, no negatives, no fractions, no decimals. When we get here, we include 0. Here we include negatives. And then when we get to rational numbers, we include the fractions and decimals. So let's use this to look at our lesson. The first example is classifying numbers. Name the set or sets of numbers to which each given number belongs. Negative 13. So where I always like to start is it rational or irrational? Well, it's not a crazy number. Negative 13 isn't crazy at all. So I'm going to start with rational. It's definitely a rational number. Then we want to look, is it an integer? Well, sure. Integers are negative or positive numbers, including 0. No fractions, no decimals. Negative 13 isn't a fraction or a decimal, so it is an integer. And then let's see if we can go down one more. Whole numbers. Now, remember, whole numbers, no negatives. And this is a negative 13, therefore it's not a whole number, and that's it. It's just rational and an integer. 3 and 2800. Again, we want to look, is it rational or irrational? Well, 2800, it ends, so it is a terminating decimal. It ends 3.28. That's the end of the number. So therefore it is rational, not irrational. It's a rational number. And we want to look now, is it an integer? Well, no fractions or decimals in here. So is it an integer? No, it's not, because it has a decimal. C. Well, C, we can automatically see it is a rational number because it's a fraction. And basically the definition of rational is ratio, which means fraction, so it's definitely a rational number. And then we look at integers. Oops, wrong way. No, it's not an integer because it's a fraction. Integers are no fractions or decimals. And finally, 42. Obviously, that's a rational number. It's not a crazy number at all. It's a very normal number we encounter all the time. It is an integer because it doesn't have fractions or decimals. It's also a whole number because it's not negative. And finally, it is a natural number because remember, natural numbers just don't include 0. So it's also a natural number. Natural numbers are just the counting numbers. Let's look at a few more, and I'll go through these a little more quickly. So negative 12, definitely rational. It has a terminating decimal at 0.0. It's a rational number and also an integer. But remember, whole numbers can't have negatives, so we stop there. 512, yes, rational. It's ratio. It is a fraction. Can't be an integer, though, because we don't do fractions or decimals for integers. Negative 4 and 6700 is rational because it ends. The decimal ends right there. That's the end of your number, so it is rational. It's a negative, so is it an integer? No, because decimals aren't included with integers. So 6, it is rational. Very rational number. It's also an integer because it's not a fraction or a decimal. It's also a whole number. It's not negative. And finally, it is a natural number. It's a counting number. 1, 2, 3, 4, 5, 6. E, I threw this one in. This one's a little tricky. So E, we can simplify. It's not in simplest form. It's actually 2. So now that you see that it's 2, it really falls into all of these categories, whereas before you may have stopped after rational.
I need all JV